Imagine a power plant so small you could haul it on the back of a pickup truck, yet powerful enough to keep a mine, a factory, or even a billionaire's private island humming for years. Sounds like science fiction, right? But here's where it gets controversial. The first real-world testbed for this sci-fi vision is an abandoned gold mine in the Idaho Panhandle, and not everyone is cheering. Welcome to the Golden Chest Mine, a weather-beaten scar on the mountainside that once echoed with pickaxes and dynamite. Today its tunnels are quiet, but the surface hums with a different kind of ambition. Idaho Strategic Resources, the mine's owner, wants to swap diesel-belching generators for a lunchbox-sized nuclear reactor, one that slides into a standard shipping container and rides the interstate on a flatbed trailer. If the plan succeeds, the company will become the poster child for the microreactor revolution, a movement that could redefine how we think about nuclear energy. But here's the part most people miss. Mini-nuke is not a marketing gimmick. At least 6 startups are locked in a sprint to shrink a technology once synonymous with cooling towers and exclusion zones into something you could, in theory, park behind a Walmart. These pint-sized powerhouses generate as little as 1 megawatt, enough for 1,000 homes, a data center, or a toothpaste ingredient factory in Wyoming. They sip helium, molten salt, or air-cooled alkali metals instead of the millions of gallons of water they're guzzled by their gargantuan cousins. Their fuel? Popcorn-sized uranium pellets wrapped in ceramic armor that the Department of Energy calls meltdown-proof. Sounds perfect for a remote mine, a hurricane-prone island, or a forward-operating military base. Yet critics wave a giant red flag. Ed Lyman, Nuclear Safety Director at the Union of Concerned Scientists, minces no words. Shipping these reactors to every factory parking lot and subdivision without off-site emergency plans is madness. His worry isn't just theoretical. A single explosion or software glitch could still vent radioactivity. And then there's the elephant in the room, spent fuel. After 70 years of promises, the United States still hasn't cracked the puzzle of permanent nuclear waste disposal. Until that changes, every microreactor site risks becoming a mini Yucca Mountain. Still, Washington keeps doubling down. Under both Republican and Democratic administrations, the Department of Energy has poured money and prestige into microreactor R&D. A fortress-like test lab in Idaho is already booked through 2025, where 3 rival designs will be bolted to the floor and pushed to their limits. Success here could mark the first new commercial reactor design licensed in the US since the Eisenhower era. Developers talk about flipping the switch as early as 2028 and dotting the countryside with these plug-and-play plants by the early 2030s. Picture the scene. A convoy rolls up to a dusty mine entrance. Workers unload what looks like an oversized garden shed. Inside are the reactor, turbine, and switchgear, an adult erector set that needs only 2 acres and a concrete pad. People hear nuclear and immediately picture Chernobyl. Sighs John Conrad of Tata Chemicals, which wants to swap coal boilers for microreactors at its Wyoming soda ash plant. We don't need cooling towers. We don't need a moat. We just need a parking spot. The Nuclear Regulatory Commission is rewriting its own rulebook to fast-track these devices, arguing that their reduced risk profiles deserve a lighter touch. Communities, however, will still get a say, and some are already shouting, without a federal waste plan, spent fuel could sit in local backyards for decades. That uncertainty is already shaping corporate decisions. Take Radiant, the California startup tapped by Idaho Strategic to supply Golden Chest. Radiant's reactors would sip fuel so slowly they'd need refueling only once every 5 years. When that day comes, the company plans to haul the waste to a yet-to-be-built storage site north of Casper, Wyoming. Locals in Bar None aren't rolling out the welcome mat. I've talked to every neighbor. Resident Mitchell Grosskopf told county commissioners, "Not a single one wants this." State Representative Bill Allemond warns that decades from now, the area could become a graveyard for hundreds of radioactive cores. Radiant counters that most elected officials and many residents crave the high-paying jobs the factory would bring. The standoff is far from over. Meanwhile, the global supply chain for the special uranium these reactors need, enriched to a higher grade than today's commercial fuel, barely exists. No U.S. facility currently produces it, and investors won't build enrichment plants until they're convinced thousands of microreactors will actually be ordered. It's a chicken and egg stalemate that could stall the entire industry. Yet demand is exploding, driven by an unlikely ally, artificial intelligence. Data centers now consume more electricity than many small nations, and tech giants are desperate for carbon-free power that doesn't depend on the weather. Microreactors promise 24/7 juice without the eye-watering price tag of new transmission lines, up to $1 million per mile in rugged terrain. By 2025, Idaho National Laboratory's domed test facility will host at least 3 working prototypes. 5 companies, Radiant, Westinghouse, BWXT, and a handful of stealth mode startups, have already inked tentative deals with mines, factories, and island nations. BWXT's Project Pele, originally conceived for remote military bases, is being stress-tested in an airplane hangar-sized lab in Lynchburg, Virginia. Engineers blast components with hydrogen furnaces and scan them with industrial CT machines, originally designed for jet engines. Down the hall, another team is adapting the same technology for lunar outposts, where a microreactor could keep astronauts alive through the 14-day lunar night. The secret sauce behind the hype is TRISO fuel, uranium kernels smaller than poppy seeds, each wrapped in 3 layers of ceramic armor. BWXT's Eric Nygaard likens it to collapsing a concrete containment dome into the head of a pin. The Energy Department swears the pellets won't crack even in a jet fuel fire or 9.0 earthquake. Skeptics counter that real-world reactor accidents can reach temperatures no lab furnace has matched. Nano Nuclear, a New York-based startup, says inquiries are pouring in from Philippine manufacturers and Indonesian officials who need reliable power for scattered islands. One billionaire asked if a microreactor could run a self-sustaining island, complete with vertical farms and desalination. We told him it's absolutely doable. CEO James Walker grins. Still, the U.S. nuclear industry has a long, bruising history of over-promising. The last large reactors to come online in Georgia ballooned $20 billion over budget and arrived 7 years late. That track record makes communities rightfully skeptical when startups promise to truck in a reactor, flip a switch, and drive away with the waste. So where does that leave us? On the cusp of a nuclear renaissance or a radioactive rerun of past mistakes? The first commercial microreactors could be running within 4 years, unless lawsuits, fuel shortages, or public backlash slam the brakes. Now it's your turn. Would you feel comfortable living next door to a reactor that fits in your garage? Should rural towns trade local risk for high-tech jobs and clean power? Or should we hit pause until the waste question is finally solved? Drop your thoughts below. Agreement, outrage, or wild ideas welcome. Let's keep the conversation glowing. Safely, of course.